everyone. Thank you for coming to my talk. So today I want to talk to you about how to build your backend with GraphQL and Serverless in Redux-style mental model. So thank you for the nice introduction. Again, I'm Marion from Zurich. And I'm a community organizer, but recently I started riding dirt bikes because before I was a mechanic for my boyfriend. And then I was like, I might as well do it as well. So I will buy my own dirt bike next month. So I'm really excited. Thank you. Yes, and I work as a developer experience engineer at Hasura, which means I'm responsible for documentation, GitHub issues, and in general developer experience. So if you try it out and you have any feedback, I would be very happy to talk to you. So let's jump into the topic. So I hope you all agree with me that Redux is awesome. So if not, maybe we can also discuss this later. And so basically, I'm not a React developer professionally, but of course, I built a React app with Redux because I wanted to do this talk. And I think it's pretty cool, even though you have to write some boilerplate code. Once everything is set up, it's really cool as a state management tool. So for those of you who are not familiar with Redux or who need a small refresher, so we have a UI component where something happens. Then an action gets dispatched, and which calls a reducer. The reducer updates state, and then the UI component that subscribe to the state then get the update. So this is the mental model of Redux. Now we said we will build this new architecture with serverless. So let's also talk about serverless. And I thought the best way to do this is to start off with an example. So here I'm defining a function. That's basically a very simple function which just returns a message that is hello world. Then I deploy this function to be a serverless function on the cloud. And then I can just call it and I get the message hello world. So this means like in 20 seconds or less, I build my own API with very simple code. And I think it's really cool to have this freedom to be able to spend the time on writing the code that we care about instead of having to deal with DevOps and operations, because serverless functions, if they run on the cloud, they scale horizontally, so you don't need to care about servers or anything. Now, the third and last component of our architecture is GraphQL. Who's already working with GraphQL? So a lot of people. To introduce this to the other people, I thought I'd just compare it to REST, which is the more traditional kind of architecture. So in REST, we have on the left-hand side 3 tables, product, brand, and category. So now, what if you want to have the product with the brand? So in this case, you would have to make an API call to get the product, and then with the ID get the brand, so have 2 API calls. Compared to GraphQL on the right-hand side, where on the top we have a query where we get information about the product, and then below another query where we get the product with the brand in one query. So GraphQL allows us to have nested resources. So this, and also the fact that you only have one endpoint for GraphQL, is why I like it a lot. Now we said we want to transfer this mental model of Redux to apply for a whole backend architecture. So how will this look? We still have a UI where something happens, but instead of dispatching an action, we have a GraphQL mutation. So we insert something into the database. Then a serverless function is called, which is the reducer in our mental model. The serverless function updates the state, and then the UI components that subscribe to this state get updated. So we have on the one side the state of the UI, and on the other side the state of the backend. So now what we'll be doing is we will have an app where we can type in bad and naughty words, but we cannot display them in our application because of many reasons. So we have to filter these bad words and return a sanitized content. Now again, with our model, how will this look? So we have bad content that somebody types in. We will save this raw content with a mutation inside our database. Then with the insert, we have an event trigger on our API, which calls a serverless function. The serverless function sanitizes the content and filters out the bad words, and then updates the state with the sanitized version, and the UI components that care about the sanitized version get the update because they subscribe with GraphQL subscription to this information. OK, so let's see for the live demo. So the first thing we do, this is cute, isn't it? The first thing we do, I already set up an API. This is a Postgres database with Hasura, which is a GraphQL layer, and it's deployed on Heroku. So we create a table called tweets. It has an ID that is a UUID, and we generate it randomly. Then the tweet has a raw version that is text, and a sanitized version that is also text, and this is in the beginning null. So this is, as we said before, we will insert the raw tweet into the database, and then later the serverless function will update the tweet with the sanitized field. So as a primary key, we add the ID, and we add the table. So what we now have is we can do a mutation, insert tweets, and we say something dangerous. And we return the ID, the raw, and the sanitized. So this is inserted in the database as expected with our content and with the sanitized field being null at the moment. So now we cannot access this API because there will be bad words in it. And so we go to our serverless function. I created this on Glitch, so it's an express serverless function. Maybe to show you quickly how this setup works. So we have a library with bad words. So I cannot show these words, they're really bad. And so we have a reducer function here. And what we're doing is for the event that comes in, that contains the information from the mutation that we create on the API, we take the raw here, the raw field out of this tweet. And then the ML and the AI, which is in this case just regex, sanitizes this tweet and returns a clean version of it that we can actually show. So it's very simple. And then what we do here is we have another GraphQL mutation, but this time we don't insert anything, but we update the tweet, and we pass the sanitized content that we create here to the sanitized field of this tweet with the respective ID. Here you can see the endpoint that we have here from our API, and the rest is just server setup. So this serverless function is created. Now we need to be able to trigger it. So we create an event trigger called sanitize on the table tweets, and we want to do it when a new tweet is inserted. So now I have to get the URL. Create the event trigger. So now let's see if this works. So now I actually have to use one of the bad words because otherwise we cannot see if the sanitized thing is working. And I found one that I can use, which is hell. So I think this is OK with the code of conduct. So I say is hell nice. And I save. And now first I want to go and see if this event was delivered, and it was. It seems like it's fine with the time. And then I go into the tweets, and I can see here that the bad word has been replaced by the serverless function. So far, we've seen the backend part is working. But now we've been talking before about the UI components that change something and then trigger an update, and also that some UI components subscribe to this data. So for this, we have a React app. And for those who already use GraphQL, you will be familiar with Apollo, but I just want to quickly explain the setup. So Apollo, we can use to access GraphQL APIs from any JavaScript framework, and then we can do queries and mutations from our front end. Then we need the WebSocket link, because we will later have subscription. So we need to have an open WebSocket for the API to be able to send updates to the front end. Here we instantiate a new Apollo client, and we pass a new WebSocket link, which is the URL from the endpoint we've seen before and from the API that we just created. In the end, we wrap the app inside Apollo provider, which allows us then to use Apollo client in all of the components that we create in our app. So let's see how this looks so far. Something nice. Now it just says dispatch. So we need to add something here. So to explain this, we import GraphQL and use mutations from React hooks. So React hooks is a way you can use GraphQL, and like a newer way to use it compared to the mutation components that you can also use with Apollo. The React hooks are used mostly for functional components. So as you can see here, this is the exact same mutation, or a very similar mutation that we created before in the UI. So it's nice that we can just, in the graphical, check if the mutation is working, and then copy-paste it to our front end, because then it will work from there as well. Then we have our arrow function here. And here we destructure the data. With Apollo client, we have automatic access to the fields data loading and error. And here we say we use the mutation add tweet that we defined earlier here. Now we don't need this anymore. And with the access to these three fields, we can say if it's loading, we display a span with loading. If there's an error, we want to display the error. And if we have data, we have here the tweet status component that we call with the data that we inserted. And the rest is just the form that we've seen before. Now, in the tweet status component, we use a subscription, because this is the place where we want to have updates and we want to know what's the status of the tweet, because if it's not yet sanitized, we don't want to display the content, but as soon as it is sanitized, we want to create to show the sanitized content. So we have a subscription here. And the same way as we were using mutations, we use subscriptions. And what we're doing here is we say if we don't have data, or if the data is not sanitized, we cannot show the data, so we're not showing anything except for a GIF that we're still cleaning the data. If there is data and there is the sanitized field of this tweet is not null, then we show the sanitized content, and also a GIF to show that now we're innocent, that we can display the actual data. So we'll see. So what can I say? I cannot say go to hell, it's not nice, but please go to hell. OK. So now it's loading. It's loading a little bit too long. So now it's cleaning, and now this content is sanitized with the stars, and we are innocent. So isn't it nice? So this is working. Let's go back. So the demo gods were nice to me. So now we've seen how we can implement also a kind of more backend architecture with the Redux style mental concept. So we have an action that is dispatched that is in our case a GraphQL mutation. The GraphQL mutation has an event trigger that calls a serverless function, which is our reducer. The reducer updates the state. The state is our GraphQL API. And UI components that care about this state subscribe and then get updates as live queries. But now let's do a little bit something more complex that is also a lot of fun. So if you're interested, use this QR code because we are ordering food. I mean, it's quite late, and I think everyone is hungry. So get on this food ordering app. Or you can also use the URL down here. OK, so now I will order. I will wait for a few more seconds. Now I want to order mango. And now you can see 4 stages here. So order validation, payment, restaurant approval, and driver assignment. So these are all serverless functions, or in our model, reducers that get called based on something that is happening. And now it stopped because it's waiting for my payment. So I have to pay 500 rupees for my mango. And it's done. So now the restaurant approves this, and the driver is assigned, and now my order is complete. Now, if I go to the Analytics tab, I can see you all ordering food. And I can also see people don't like to pay for food because the brown and red lines are approval and validation, and the green one is payment. But then we just get free food, it's also fine. And so what you can see is all these lines are UI components that subscribe to these serverless functions and then get real-time updates. So let's look at something more complex. So my friend Shahid is ordering 1,000 items of Indian food at the same time. And this is what I was talking about, the scaling before. If you have a serverless function, you don't need to care about scaling, because with the cloud providers nowadays, you have horizontal scaling. So now 1,000 orders are being approved, which is done, and now he pays all of them. So, and now let's simulate a failure, network failure. So let's say to AWS servers, the land label was disconnected, and we're like, oh no, what about our restaurant business? Because some of these orders are in the middle of being processed, and we might be scared that we will lose all the data because maybe some of the orders were paid, but then in the middle they just get this function start running, which you can see here. It's completely come to a stop. And if we go to see the order page, we see here an example where one order is stuck right in the middle. So it's in the middle of the restaurant approval serverless function. So now we go back to AWS, or we found the LAN cable to put it back in the Amazon server. And we unthrottle the function, and we save. And then we can see that these functions just pick up where they left off. So nothing is lost because there are subscriptions to the state in our GraphQL API that save the current state. And when the functions continue to run, they just get the current state and can continue from where they left off. So to summarize this, we have a new order. And in the beginning, so we also have an orders table in our API. In the beginning, everything is false. It's validated, is paid, is approved, and is agent assigned. It's all false. Then the first serverless function gets called, and we want to validate the order. Then it's validated. We change it to true. Then the second serverless function is called to check the payment. When this is fine, is paid becomes true. Then the restaurant needs to approve the order, and is approved gets true. And finally, we need to assign the order to a driver, and then also the last is agent assigned becomes true. And what you can do here, you can choose if you want to go through the whole process and then send the whole result back as a mutation to your API, or you can have real-time updates after each serverless function to get an update on the UI, which is probably what you want for a food ordering app, because I want to know if my food is on the way or if the restaurant approved it. So this is how it would work for a food ordering app. And it's completed. So this is everything for me. You can check out the Dangerous Tweets app on my GitHub account. There's also instructions what you have to add in your in the Hasura project, in the Glitch project, and in your React project to make it work. If you have questions or want to talk about this architecture, if you have different ideas of how we could do this, I would be happy to talk to you, and also have a lot of stickers and some t-shirts if you're interested. So thank you very much.